All right, so we're going to go over questions from 6.4 in the workbook for Math 20-2. So the question we're starting with is number 4, and it says use graphing technology to create a family of 3 parabolas with each property. Provide the equation that defines each parabola. So this one is a little bit tricky to kind of lead you in because there's lots of different options that you could kind of go with here. One of the things that I kind of found tricky at first is understanding that they want you to do one set of parabolas that have these what would you call it, characteristics, I guess, and then one set that has this characteristic. So just being aware that you're not looking for both of these points in your set of parabolas, because that would be pretty difficult, or maybe actually impossible. So all you really need to do here is remember the general form for like the vertex form of writing a quadratic equation. So basically it's y is equal to a times by x minus h plus k. Okay, and the really important thing for you to understand is what these different parts are. So a is a value that's going to affect, like we've already looked at how it affects the direction of opening. So is it going to be open up or down? Direction of opening. And the other thing that it's going to affect is the shape of the graph, so basically the width. So we talked a little bit about how numbers that are like greater than +1 or less than -1 are going to be increasingly narrow, and then numbers between 0 and +1 or 0 and -1, so basically like decimal values, are going to make the graph wider. So shape is the other thing that's affected here. Then we have the other thing here would be h, which is the x value for our vertex of our graph. And the other thing is k, which is our y value of the vertex. Okay, so all of these components kind of tell you important parts about the graph. So in the first one, they're saying to you, you want to come up with a graph that has the same, a set of graphs that have the same shape, direction of opening, and axis of symmetry. And actually, sorry, I should have mentioned that remember that the x value of your vertex, like if we look at a graph, like there's one up here, remember that the x value of your vertex is also your axis of symmetry, right? So this h value gives us the value of our vertex and the axis of symmetry. Forgot to mention that. Okay, so if we want the shape and direction of opening to stay the same, that means that all of our formulas have to have the same a value. And if we want the axis of symmetry to be the same in all of them, that means our h value has to be the same for all of them. So all that really matters is that your k value can change, but your a and h values need to change. So basically what I did is I went into my calculator, because it says to use graphing technology, and I just chose a random number. It's probably best for these types of questions if you choose smaller numbers, because that way they'll fit into the standard graphing window, which just makes things a little easier. So I chose -3 as my a value, and that has to stay the same for all of them if we want them to have the same shape and direction of opening. So -3 I kept the same. Then I'm going to follow the exact same format, so then bracket, and then x, and because we want the axis of symmetry to be the same for all of them, I also had to choose one number here. So I chose -1. X minus -1 is going to be x plus 1, so all of my brackets are going to be x plus 1. Oh, and I forgot to put in here that that's always going to be squared. So square the bracket, and then the only thing that's going to change here is your y value of your vertex, so basically where it's located vertically on the graph. So I did 1 plus 1, 1 plus 3, and 1 as -2. Now, if you do all 3 on your calculator, I don't know if you would have ever seen this before, but basically if you have all 3, you can see that this first graph is going to be represented by a blue line, the second graph will be represented by a red line, and the third graph will be represented by a black line. Now, if you have an earlier version of, or a simpler version of this calculator, I can't remember exactly how. I think they differentiate with like maybe like dashes or lines, or you might just have to graph them separately to see them. But basically what I can do is now I can go in and see. So there's the first equation I did. There's the second equation I did. And there's the third equation I did. So you can see that they all open downwards. Shape, it's kind of a little bit harder to see because they're offset from each other to see, but you could always count that they have the same width at a point. And then the only other thing would be that their value of their x-axis of symmetry would be the same, and you can see that they're all running through x equals -1, which is what I chose for that value here when I put in x plus 1, and so those all fit those requirements. Now, if I was looking to do the other one here where the vertex always stays the same, because h and k are my vertex values, all that would matter is that I make a set of graphs where h and k are always the same. So if I go back to this, I did do a second one where I basically made it, so the only value that can change is your a value. So basically I deleted my a value for the first one, which makes the a value basically just +1, and I did x plus 1 plus 1. Or no, sorry, I did x minus 2 squared plus 3 for my first graph. And then for my second graph, so again, your a value can change, so I just made it negative, whoops, now I deleted it, -1 bracket x, and now because our vertex has to stay the same, the rest of the equation has to stay exactly the same, so it's going to be x minus 2 bracket, square that, plus 3. And then my last one I did as +3, x minus 2 squared, and then I did plus 3 here. So now if I graph these, the only thing that should change is like the direction of opening and the shape. So here you can see pretty clearly, right? This last one is quite a bit narrower because it had a value greater than 1. And then these two have the same shape because they're basically like, this one was +1 and this one was -1. So the only thing that's changing between them is the direction of their opening. But the vertex for all of them is at the same point. Okay, so that's how you would solve number 4. The next question was number 5. So it says the parabola shown is the graph of function g of x. What are the coordinates of the vertex and the y-intercept? So this one you already got, but since we're going to need it for the next part, I'm just going to go through it. So our vertex is right here, which would be at y is equal to 3 and x is equal to 2. So it's going to be 2, 3 for the vertex. And then for your y-intercept, it crosses over halfway between 4 and 6. So that's going to be 5 on the y and 0 on the x. So 0, 5 is our y-intercept. Okay, so now that I have these two values, it asks us to write the equation in vertex form. So basically what I want to do is set up my general kind of formula, y equals a, and then it's going to be x minus h, so x minus the x value of our vertex, which was 2, so x minus 2, and then plus the y value. So because our y value is positive, it's just going to be plus 3. Then it even tells you here how to do this. So if you want to solve, oh no, sorry, it says substitute values, you know, for h and k. Okay, so we already did that. Now, if you want to determine a, it doesn't actually mention this to you, but what you need to do is fill in values for y and x from a different point that you know on the graph, so that the only unknown variable in your formula is a. So basically what I would do here is say, okay, the other point that we know is the y-intercept. So my y value there was 5, so I can put that in. 5 is equal to A, we don't know, times by bracket x, which our x value when y was 5 is 0. Sorry, I keep forgetting to write that the bracket is squared. 0 minus 2 squared plus 3. Okay, and so now basically what I want to do is start isolating A. So I want to move, the first thing I would do is move this 3 away. So I'm going to subtract 3 from both sides. So 5 minus 3 is 2, and 3 minus 3 is 0. So I can say A equals, and then I'm just going to simplify. 0 minus 2 is negative 2, and I want to square that. So negative 2 squared is 4. So I have A times by 4 is equal to 2, and then I need to just divide away this 4 from both sides. So now I know that A is going to be equal to positive 1/2. And so now if I wanted to write my full equation, it's just going to be the same as this with my A value substituted in. So it's going to be y equals A is 1/2 x minus 2 squared plus 3. So that's my final equation. Okay. Next one we have 6b. Jasmine throws a softball to Lauren. The height of the ball ht in meters. T seconds after Jasmine's throw can be modeled as h of t equals negative 4.9 t minus 0.8 squared plus 4.5. So basically if we think about what's happening there, this value is always going to be our y value. So on our graph, height is represented on the y-axis, and this is always going to be our x value. So t is on our x-axis. And so basically, it says use technology to graph the function and determine its zeros. So we're going to go in, clear out any formulas we already have in there, and input our equation. So we're going to put in negative 4.9 bracket x minus 0.8 bracket square that plus 4.5. Okay, and now we can go to our graph. And here we are. So we wanted to determine its zeros. So we're going to use second function trace, use the 0. And so left bound is right bound and guess. So we end up with our first 0 is negative 0.158. And then of course the y value is 0. And our second 0 is left bound, right bound, enter 1.758 and 0. Okay, so those are my zeros, and then it says, do either of these zeros have meaning in this situation? So if you think about the fact that our x values, so our y values are 0, so basically that means when height is 0, so basically when the ball is on the ground. And then we have these other components here, x, which is actually time. So we can't have negative time, so this value has no meaning in this particular scenario. But at 1.758, so we saw that the graph kind of went a little bit like this. Okay, so at 1.758, what that means is after 1.758 seconds, the ball that got thrown up has come back down and landed on the ground, right? Because it said the other girl misses the catch, so it goes right to the ground. So basically we could say it took 1.758 seconds for the ball to hit the ground. Okay. Question number 7. A plan for an arch in the shape of a parabola is drawn on a grid with a scale of 1 meter per square. The base of the arch is located at the point 0, 0, and 15, 0. So basically they're setting us up on kind of like a graph grid where we start at 0, 0, and then we go to 15, 0. And it says that it's like an arch in the shape of a parabola, so we know it's going to go kind of like that. Okay. It says the maximum height of the arch is at 18 meters. So it doesn't really say that in here, but because the shape is basically like a parabola and it imitates the shape of an arch, we know that the y-axis is going to be representing height and then the x-axis is representing width of this arch. So basically here at the height, we know that our y value is 18 meters, okay? But we don't know our x value. So what you need to think about is, remember the x value of your vertex, or the highest point on this arch, is going to be like a line of symmetry. So that means it's going to be exactly halfway between the two different parts of the arch. So if the bottom of the arch goes from 0 to 15, then this is going to be halfway between them. So basically 15 divided by 2 equals 7.5. And so that's going to be our x value here, is 7.5 and 18. So now that we have a bunch of different points on the graph, we can easily write a quadratic function to model the arch. So basically we can just say y is equal to a x minus h, which is our x component of the vertex, so 7.5. And then it's going to be plus the y value, which is 18. And we need to square that. And then we just go through the same set of steps I showed you before, where we're going to have to plug in a different set of values for y and x, one that is on the graph, in order to solve for a. So basically we would say, let's see, y, let's choose, I usually don't choose the origin just because the zeros, I don't know why. I feel like they can mess things up even though they shouldn't, but so I would personally just choose this one. So I'd say when y is 0, we have a equals x, which is 15 minus 7.5 squared plus 18. Then I want to move this 18 to the other side, so I'm going to do negative 18 equals a 15 minus 7.5 is going to be 7.5. And if I square that, I'm going to get 56.25, so negative 18 equals a times by 56.25. And then when I divide that out of both sides, 56.25, 56.25, I'm going to end up with a is equal to negative 0.32, I believe it was. Just double check that. Yeah, so that's our a value. So now I would basically just, to write my proper quadratic function, I would just go ahead and substitute that a value in here. So my final function should be y equals negative 0.32 times by x minus 7.5 squared plus 18. Okay. All right, and then you can state the domain and range. So it's going to be, let's see, x could be equal to all real numbers, and y is going to be, let's see, less than or equal to 18, and other than that, y can equal all real numbers. Okay, and then the last question was number 11 here. Determine the vertex form of the equation for this parabola. So same exact idea, you're just looking for the different points on the graph. So we can say our vertex is at, let's see, the x value would be negative 3, and the y value would be negative 1. And an other easy point to pick would be the y-intercept, which would be 0 for x and 2 for y. And then we can just plug it in. So y equals a, x minus our x version of the point on the vertex. So x minus negative 3 is going to be x plus 3. And then plus our y value. So plus negative is actually just going to be minus. So I shouldn't have put a plus in there yet. So minus 1, and oh, and I need to square that. There we go. Okay, then I can substitute in my values from my y-intercept. So y is equal to 2 when x is equal to 0 plus 3 squared minus 1. Okay, so then I want to move this over by adding it. So plus 1 is going to cancel this out. 2 plus 1 is 3 equals a. 0 plus 3 is 3 squared, which is 9. So I'm going to divide out. Actually, here I'll just write it out. So 3 equals 9a. I want to divide out the 9 from both sides. So I'm left with a is equal to 3 over 9, which we can reduce to simplest terms, which would be a third. And now we can just put that back into our original form. So it's going to be y equals 1/3 x plus 3 squared minus 1. Should be our final version of that equation. Okay, so hopefully that helps you out a little bit with the vertex form, and I will see you next time.